Okay, so let's finish off what we didn't quite get to today in our lesson in class. So there's another interesting idea about functions, and this comes into play for, I don't know, for a lot of important reasons later on, but functions can also be even or odd. Now, I want you to be really careful and make special note that this is not the same meaning of even and odd as it is with numbers. So I'm just going to write here that this is not the same as numbers, so you can't just assume what we mean when we say even and odd for functions means the same thing. Okay. There are some qualities about these that could be relatable, but for now we're just going to learn what it means for a function to be even and then odd. So essentially, put in function notation terms here, in words I would say opposite inputs create equal outputs. So if you have an even function, what it means is if you put an input into the function and it's opposite, right? So the positive and negative version, it gives you the exact same output. So f of negative x is the same as f of x. So perhaps the best one to look at actually as an example, we're going to jump to that first and then talk about the graphs, would be f of x equals x squared. We know that, for example, if I put a or negative a, right, so let's just say that's, and we know that this is a parabola, we know that those two opposite inputs create the exact same output. So any graph that's even has this quality to it that it has some symmetry here. Because what we mean is if we go back an equal amount as we go up, they produce the same exact output. And what this does is it makes the graphs have y-axis symmetry. Okay, so the special thing about even functions is that opposite inputs create equal outputs, which creates y-axis symmetry. And the honest truth is, any random graph that has this symmetry, so I could make another weird graph like this, so let me just draw some funky thing in there on that side. And if I want to make sure that it is an even function, I can simply just reflect it across the y-axis like that, and we'd be good to go. Because again, if you were to go back, out a certain amount, let's just say right here, let's call it b, and negative b, then that outcome, right, and that one are the same. And no matter what, if I go up any amount and back an equal amount, then it's going to give me the same output. Like 5 minutes or something?
Give me the code I'm going to go do a video real quick to get a surfboard. Thank you, sir.
Okay, so let's move on to odd functions. There's something similar about odd functions in their definition, but we will and we'll look at it in a similar way here. So this one has another definition we can use function notation for, but you'll notice it does involve opposite inputs, right? So if you take the negative input and put it in versus the positive version of it or whatever, like the opposites, then you'll notice the function outputs are not identical, but they are also opposites actually. So opposite inputs create opposite outputs, which also has some interesting graphical interpretations, just like even functions did. Okay. So another example for this, and this is interesting because it kind of is related if we use a power function, like x squared. Perhaps the most basic odd function would be x cubed, and you might notice that the power here being even goes with an even function, and the power here being odd goes with an odd function. But it really depends on other things too. But let's take a look at this graph. Now this is one of the basic graphs that we've been learning that we can be familiar with here. And this graph we know kind of goes up like that over there, and then kind of comes back down like that over there. And again, it's almost like a little bit steeper of a parabola, but that's been bent downwards back here, right? And this one's interesting because if we put in, let's say, just some random input there, a, then of course this is a cubed. But if I put in negative a, that's not going to be identical, it's actually going to be negative. And that makes sense when you cube a number. If you cube a negative number, the outcome is going to also be negative, right? So this would be negative a cubed in this case. Whereas when I square something, whether it's positive or negative, you get an identical result. But this one you get opposite results. So this also has some symmetry if there's any graph that is odd. And that kind of symmetry is actually rotational symmetry. Okay, so you can say rotational symmetry. And sometimes we call it about the origin. Sometimes we specify the amount of rotation. In this case, it's 180-degree rotation, right? If you rotated this 180 degrees, it would be identical to itself, right? So again, odd functions, opposite inputs create opposite outputs. And the characteristic of their graphs would be that they have this 180-degree symmetry to them if you rotate around. Okay, and that's not to be confused with x-axis symmetry. You could not reflect it across the x-axis and be identical because that would make it go the other direction, right? So it has to be a rotation. And again, you could draw a random graph. You know, put something there and then make it have that symmetry. Although since it has to be around the origin, the interesting thing about an odd function is that an odd function needs to go through the origin in the first place. So I could just draw some random thing there, but then if it does that, I need to have it mirrored down here. Let's see if I can do it. Yeah, that's pretty good. Okay, so this would be one where if you rotated around 180 degrees, it would look exactly identical to itself. Okay. Now this actually comes into play with like polynomials. We can have a polynomial that is longer than either of these things. Let's just say we have g of x equals 3x to the fourth plus 8x squared. Now this can be shown that it is even because if I just find g of negative x, and remember we're not going to plug in specific numbers, we need to show that it always is going to give me the same thing. So remember, an even function, reminding ourselves, has the quality that opposite inputs create equal outputs, meaning if I put negative x into the function, I should be able to simplify it so it is identical to the original function itself. And watch this. If I replace the x to the fourth and the x squared with negative x, then it becomes this. But then after that, negative x to the fourth is just the same as plain old x to the fourth, right? Because it's a fourth power, it's an even power. And then this one is the same deal, where it's just x squared. So you can see that g of x and g of negative x are actually identical to each other. So this function itself is an example of an even function. Now, if we had a situation where, let's say we had another polynomial, so let's call it h of x, and let's say we had the same start, like 3x to the fourth plus 8, but let's say it was 8x cubed, okay? This piece of it is odd, but this piece of it is even. So if I actually want to know if it's even or odd, it's actually neither, okay? So here's some basic examples. Now, most of what we've studied so far have been polynomials, but there's a lot of other graphs that also can be said to be even or odd. In fact, if you wanted to look back at the basic graphs, the list of basic graphs that we studied, there is actually another odd function that's of interest to us here that we could, put in our list of graphs here, and that would be the one I'm thinking of is y equals 1 over x, because if you remember, it has these two branches like this. I'll draw that a little bit better. Some of you noticed it has this kind of space where it never gets to 0, and then it has this over here. And if you remember when we talked about having 180-degree symmetry, this is the same deal where if we rotated it around 180 degrees, it would exactly be identical to itself. Okay, and again, that makes sense, right? Because look here, if this was a, right, this would be 1 over a, but if you went back to negative a, then whatever this output matches with here. I didn't do it perfectly, but that would be negative 1 over a in that case. So again, if you have the opposite inputs, they make the exact opposite outputs of itself. Okay, so that's something that is worth talking about and thinking about with functions on top of the other stuff we've looked at, and we will call that good for the rest of our notes for this lesson.